Good morning, friends. So let's implement the stack, our first problem that we have to implement stack in Java without using any standard Java collections. And we are given the StackI interface here. So I have got my IntelliJ open here, and I already have this interface, which has got pop, push, and peek methods. So first of all, let me create a stack node first. So what my plan is that I will create a stack node object, which would be having this element st, a generic element t, and there would be a top pointer which would be pointing to this. Or maybe I can also create a sort of like list, a linked list type of thing where we will be having a next, where each node is pointing to the next element which is above it. So I will go here and I will first of all create a Java class. So alt insert Java class stack node. Okay, stack node. I'll call it a stack node. And I will make it generic because we have to, in our StackI interface, it's a generic type of class. So I will do the same. A stack node, which can take any type of object to be inserted. And the data for this stack node would be, of course, this state element type T. And I will create a next node, which is very much similar to what we do in the linked list. So stack node T, which is next. So what it means is that, for example, if this is, if this A is our stack node, the data would be A, and the next would be pointing to B. Okay. So I will just create some constructor here. I'll create a constructor and just taking data, and I will create some getters and setters methods. So alt insert getter and setter for both data and stack node next. And I think that's it for this class. Now let's implement our main stack class. So I'll call it as my stack. So again, I will go to alt insert. I'll call this as my stack. Okay. I will make it generic again. And as given in the problem statement, I have to implement this StackI interface and implement all these three methods. Let's go here, implements StackIt. Okay. So I have to alt enter implement methods, put it here. Okay, so we have got this stuff now. Now let's implement this. So first of all, it's only like one thing that I need to maintain here at the class level, which is the top thing, the top that we are pointing to. So in this diagram, as we see, we are talking about this top. This is at the class level. And let me give some space here. Okay, now first implement the pop method here. So first thing we have to check that if, say, top is equal to null, right? It means that the stack is empty and we cannot return anything. So in this simple first implementation, we will just, if the top is null, we will throw an exception. Okay, so let's check this. If top equal to null, throw new. There's already an empty stack section available, which we can just directly import it, which has the same semantics. Okay, now I will put finally item top dot get data. What we are doing is that top, if top is not a null, it means that it would be having some data which we have to return back, right? So this is what we need to do. And now we have to update the top now to top dot get next, and that's it. Return the item. So let's revise what we have done. First of all, we check that if top is equal to null, then of course we cannot return anything, and we have to throw an exception to the client. And if it's not null, then we have to get the data out of it and store it in a variable. And then because we have to update the pointer now. So here, if you see this pop, so top was pointing to C here. We stored this C into this item variable, and then we moved top to get next, which means that top will from here it will point to the next, which is B. So in the early statement, I said that the node that we are creating is like pointing to the next node, but it's opposite way. Whenever we create a stack node, the next would be the one which is bottom to it. Similarly, is happening is that when top is pointing to C, we store this element temporarily, and then when we call top.next, the next would be this node B, which is just below this C item, and then finally we return this C because we have already updated top. So this is the simple algorithm that we have used to implement pop now. Now let's implement push. Now for push, it's quite straightforward because it's not a bounding stack in our first implementation. So it doesn't matter that if there's any element empty is there or not, or whether the stack is full or not, because there's no capacity involved here. So it's quite straightforward. We just create our stack node from the given item in the argument. So I will create this T node is equal to new stack node, and I will pass this item. This is the same thing which we have been created in this constructor here. So we are calling this constructor and creating this stack node object. That's it. And now we have to just take care of that. The next pointer should be pointing to the top. So because we have to sit on the top of the current one. So set next, I will point it to top. And then top would be updated to be the same node as, because the node is the new top now. So what is happening is we created our first node with the given argument. We have a node here. And now, because say, for example, top would be already pointing to say B here, right? So suppose before we insert this C, push C in this stack, top would be pointing to B. So what we are doing is that once we created the stack node object, the next we point to the whatever is top is pointing to, which is the C dot next would be B here. And now because C is our new top, we update top to C. Okay, this is what is happening here. We node dot set next is top. So top was pointing to B before, and now node is pointing to C. So C dot next would be B here, and then we update the top pointer to C. This is very simple implementation. You just need to take care about to updating the top in both of these items. And for peak, because we are not going to return this element, so we don't need to update the top. So it would be very straightforward implementation. So we have to again check whether it's not null. If it's null, then it will throw in the empty stack exception. Otherwise, it will simply return top dot get data. That's it. Okay. So this is a very simple implementation that we have done without using any Java collection classes, which was asked for this first implementation. We just created our stack node, have a data and a next pointer. That's it. And we have got some getters and setters and some constructor. And then we implemented all these three methods as discussed. Now let's write some unit test case to test all these operations, pop, push,